Okay, let us go ahead and get ourselves started again. Let's take stock of where we are first, just to sort of understand in the process what we've actually accomplished. We've pulled some values out of Excel and actually used them now to change our Revit model a little bit. And as subtle as it seems, or as simple as that seems in terms of this change in the color, realize that's actually a very powerful thing we just accomplished, in that as much as I like working in Revit all the time, and perhaps you like working in Revit all the time, a lot of times people don't have Revit, or they need to contribute and collaborate on your process and do it in a way that doesn't involve working directly in Revit. So the ability to match things against Revit objects based on some sort of a dictionary value, some sort of key we can match them on, whether it's the element ID or something about the naming that we can match on, and be able to change things in your Revit file opens up the door to all sorts of people who may contribute. Maybe people who are buying things for you and they want to put in cost information for you, but they don't actually want to get into the Revit file. They just want to, based on a certain index, give you URLs for purchasing or cost data or vendors or whatever it is they're doing. But you can start maintaining data in two places and keep them synced up with each other. So just to sort of illustrate that, if we are over here, and for example, we decide for whatever reason that the occupancy load limits change, something about the targets, or even the colors decided to change. If we decided that the mechanical room wasn't going to be this kind of bluish color, but it was actually going to be a much darker color, we could go through and change that. Let me put 0 and 0 in there. I'll just give it a very pure blue color. So what will happen is, although I've made the change in Excel, if I come back and rerun the Dynamo, in this case, it doesn't look like it changed. Let me think about why that is, because it should. What's going on? Do I have those in terms of the mechanical? Let me just kind of check, because I would have expected that to work. In my list, which value is mechanical? Mechanical is the very first one, so if I look at the colors, it looks like it isn't reading the colors right now. This could be this whole notion about goosing things. If it doesn't think something changed about that file, in fact, let me go ahead and save that file. And then try goosing this along to get it to read its value. Yeah, Tom, what you got?
If I wanted to jump in.
You were going to jump in with us in just a second at 3A.
Okay.
Then come over there. Let me save that away. Okay. Then we come back over to Revit again. See if we can get them to read that again. There's always this funny thing about getting it to sort of come back and start over or kind of goose its values. If I run that, let me see if it makes any difference. If not, I'm going to try reselecting the file. Okay, it says run completed, but I don't think it's actually looking up the new values yet. Nope. So let me go ahead and reselect the file, because I just don't think that from its perception it thinks anything has changed. So again, I'll reselect the file. It did change for you? Mechanical, it should be there. Mechanical here, I got the color. It's got the color here. It doesn't look like it's changing the color for me. What's your secret? Because, actually, at this point, I know that something hasn't updated. Let's go ahead and see if I can debug this. So it's not getting the value for me down here. Let me come back over here just in terms of the list of colors right here. If I have reread the file, what should happen is down there in mechanical, and it looks like there's the alphas. It's still 139, 166, 178. So I can tell that for me it hasn't updated somehow. For some reason, this data over here is still showing the old values. So let's see if we can figure that out again. Am I saving it to the wrong place? Am I, because it's all these different things. Let me see if I'm making sure I'm reading the right one. That one looks like it was at 11:45. That should be okay. That should be fine. Try running that again. Again, it's not changing it. Interesting. So, yeah, at this point, I think it's just sort of more an updating thing as opposed to anything else. What can I do to get that? What's that?
Have you saved the changes yet?
I think I did, but maybe not. I thought I did, but I always use a little bit of Control X and Control L, whatever. It's a little hard to tell sometimes. Okay, so it's there. It's there. Mechanical should be there. Let me do a save. I'm just gonna do a save as even. On my machine, you're never quite sure what's going on. So I come back in, I'll find that one. I know that's the new one. Okay, that time it looked like it updated. Let's see what it's coming up with instead. Okay, that's updated. So now theoretically, there it is, that dark blue color. Okay, so some sort of version and file control thing in terms of just how I'm organizing. But let's get everyone caught back up. So we read some data file. We were pulling values out of Excel. We were able to make some changes. They kind of pop over here into Revit and adjust that. Here's where we're going in the big roadmap. We set the color based on the occupancy. What we want to do is basically for each of those different rooms, we want to say, hey, let's look up the occupancy load factor for each room, very much when we looked up the colors. We're going to divide each room's true area by this occupancy load factor and just figure out how many rooms have more than 50 people in them. Okay, so Miss Dom, please join us on 3A and we'll put that all together.
Question about the list match with key values. Do
Yes.
we need to download that?
There is, yes, there is a node we need to bring in, a package we need to bring in. There's Clockwork is one of them that's already probably on your machine. Or no, you have Lunchbox. Go ahead and download Clockwork. So under packages, search for a package. And if you could look for Clockwork for Dynamo 0.9 and bring that one in. Super. That'll now install that custom node. There's a very useful node in there, which is all about indexing and building a dictionary. So let's go ahead and I'm going to open up 3A and we'll do the same thing. So in this map, we are basically in a very similar sort of place. We had already looked up all these matching key values based upon the colors. So we fed in the sequence. We have the keys that we're looking up against. That's the list of rooms from the Excel file to match against. The values we pulled out with the color values. We're going to do something entirely analogous. What I want to do is now, based upon actually not the list of, well, no, based on the occupancies, what I want to do is look up the matching value from Excel that's going to have the occupancy load factor. And let's take a look where that is. So right next to this node, this loading listing match with the key values, where we're looking up the RGB values, we're going to go through and instead pull in, again, we're going to match kind of the list of occupancies. We're going to match it against the dictionary down there. But for the values that we're going to pull in, instead we're going to pull in the occupancy values. So if you can, scroll on down and see if you can find the occupancy values. They are right here. And if I pull those into the values, again, based on the occupancy name, I'll look up in that list. Let me go ahead and run this. You'll see we have the occupancies here. For each of those, we should be looking up the appropriate value in this list. So, for example, for room number 1 over here, which is a conference room, it looks up over here, it says conference is room number, type number 3. It should be returning 15. So this is returning at the 0th place 15. Similarly, for the 8th place, it's circulation. So it looks up over here in the list. It says, oh, circulation is item number 1, or index number 1. Therefore, I'm going to return index number 1, which is 5,000. So that's why the 8th index has a value of 5,000. So it's just going through and matching. Okay, let's pause there for a second and see if people get that part to work. So you're looking up based on your rooms over here and this dictionary, you're looking up these values so you have the right one-to-one correspondence for every room or occupancy type.
I'm getting no.
You're getting some nulls? Let's sort of see what we got. Okay.
This
So,
is going to be the thing.
okay, rooms is fine. Let's go on down and let's just kind of check to make sure these are all fine in terms of the actual occupancies. Let's go on down to where the data file is because I think it may be happening down there. Let's see what we got. You have that. Come back over here. You have that. That's looking pretty good. Okay. Let's come back over here. We have all sorts of things there. We have those are matching. And this over here, the colors I think are probably okay.
I'm getting an error with this. I don't know why.
Okay, let's go back and take a look at what's going on. We have these things. Can you expand? That one's null. I'm just not sure what's going on right there. Oh, because we're matching values and we're matching keys. It should be, but again, you know, I don't know. It's a little bit hard to debug kind of coming in.
Are there values missing from here?
Okay, for values, let's go ahead and try pulling that in. For that, we're going to basically bring in those values. Okay, let's try running that. Okay, again, that's null. So let me just do a little poking around for a second because it looks like somehow I'm wondering if perhaps this is just not. Have you restarted this node since like loading that in?
No.
I would try that because I
Okay.
think your logic is quite okay. I think
So
that it's
save
actually.
this? Or
Yeah, go ahead and say that. And then just restart Dynamo and let's bring it back up again.
Okay.
Okay, how are we doing in terms of grabbing all those values? We got values? Okay, if you've got values, let's go ahead and link it all together. And how we're going to link it all together is for each of those different rooms, you have. Hang on, I'll get this out of the way there. You have a whole series of different. We have the actual areas over here. We have the occupancy load over here. What I really want to do is just divide through the area by the occupancy load, and that's going to tell me how many people theoretically are in each of those rooms. So you'll see that this one is already connected to the area. What I need to do is just basically bring down the occupancy load for each of those right here. And when I run that, I should get a list of just different how many people are in each of those rooms. So you can see that we have everywhere from 59 people, 87 people, down to 4 people. We have a number of different people down in there. And what we're ultimately trying to do is figure out how many of those rooms have an occupancy of greater than 49. Because if you're 50 or greater, we're going to need the 2 different doors. And to do that, just take that and pull it over to this code block. And what that should return for you is a whole series of different true, false values. Okay, where the trues are the rooms we care about. Okay, super.
Got it.
I was worried, but it worked. Okay, so if you have a whole bunch of true, false values, you're in such good shape. Here's what we need to do. We need to figure out which rooms now have those, and here's how you do it. You have a list of rooms kind of hanging out over here to the left somewhere. You have a list of true, false values, okay, which is based on the occupancy and whether it's greater than 49. There's a fabulous function called filter by a Boolean mask which if we apply this Boolean math to the list of rooms, will give us as true the rooms that have greater than 49, as false doesn't have the rooms, or has the rooms that are not greater than 49. So if you want to go through and put that together, let's go through and open 4A. Here's how it works. We go through and we have a filter by Boolean mask. What we feed it is the true false values over here. As the mask, what we feed it as the list is just the list of different rooms. So if the list of rooms and the mask comes together, what that'll give us is just a list of the rooms that are in, or the list of rooms that is out. Okay, so if you run that, you should see that you actually have two different rooms that are considered to be in right now. I mean, we have a little bit different based on what your values are, but again, what it's doing is for every one of the different items down there that has a true, you should have an item that comes out of the Boolean mask filter. So let's just pause there and see how that's going. So again, I have trues and falses down here. And based upon those, I'm going to get a number of rooms out. So let's kind of check. Doing good? Doing good? Excellent. Okay. So if you have a list of rooms that now we know which rooms need more than 2 doors, we can go ahead and start doing all the calculations. And here's what we want to do. If you know which rooms have an occupancy greater than 50, let's go ahead and get the list of doors in that room. Because here's what we're going to do. We're going to get the list of doors, and then we're going to count how many doors are in there, and based upon if there's more than 2 or 2 or more or not, we'll go ahead and highlight them somehow to kind of indicate the rooms where there aren't enough doors. So there's going to be a fabulous function called room.doors that we're going to use. That's part of that whole clockwork suite of functions. And we will find it, I believe, just to the right over here. Okay, room doors is very much like room windows was just a little while ago. What we're going to do is we're going to take this list of rooms and we're going to feed this list of rooms in as the ones that we want to consider. So we can take these rooms right over here and say those are the ones we want to sort of look for. Oh, actually, I will take this back. I'm going to do it a slightly different way. What I want to do is actually do a list map because I want to consider this for every room independently. I don't want it as, it's that whole thing. So let's go ahead and bring this up to here as the list. In terms of what to search for, we're going to, again, look for the rooms. It's this whole thing about the phases is really what element in our phase and Revit we're currently at. We're going to go ahead and just choose the first, or the phase at index 1. But this is basically going to return a series of, or a list of the doors. So I can even put a little watch in here just so we can sort of see it all. What's that? Phases are in Revit, it's this whole notion of there's different time periods when things get built, and our document has 2 phases, one called existing and one called new construction. So you can sort of isolate what point in time you're looking at. By going to...
And that's built into the Revit document. You
Yes.
created that.
So there's 2 phases over here, and how you sort of spot it is back over here in Revit. If I go to Manage, you'll see there's a couple of different phases. Okay, existing and new construction. And when I put in the doors, I put them in the new construction phase. Okay, you're sort of getting around a layer of complexity that Revit allows for us. So I'm going to pull things from the newest phase. Let me say do a list map and get the list of doors. So what I should do now is get basically two different lists. I should get a list of doors in room 1 and a list of doors in room 2. Let's see what's happening here. Great. Okay, so for one of the rooms, which has more than 50 people, you'll see I have one door. For the other room, I have 2 doors. Okay, so the idea is with this information, we ought to be able to do something interesting. What I want to do ultimately is I want to go through and count those doors. Okay, so for each of these different rooms, I want to sort of say, hey, do you have greater than 1 door? Or do you have 2 or more doors? Okay, so if you can imagine, that's probably a list count. Okay, this is interesting. I usually put things in list maps. Let me see if it'll work without a list map. I'm hoping that gives me a count of, nope. Oh, that's the count of the outer list. Okay, never mind. I do need to do a list map. Because I don't want to count the things in the outer list. I want to count basically how many items are in each item of the list. Okay, so I'm hoping that's going to say 1 and 2. Of course, I probably need to go through and do a watch on it so I can actually see that. Okay, there's 1 and 2 in there. So here's the deal. What I would really like to do is have now a Boolean that sort of indicates whether or not there were greater than 1 door in there. Okay, so I can sort of say number of doors greater than 1. Of course, I'm not spelling very well, but that'll work. Okay, so what I'm going to do is feed in, this is the number of doors. So this should now give me, hopefully, false and then true. So now we can go through and take our list of different doors, or list of different rooms, and I can basically go through and filter it down based on this, so that the ones that already have where it is false, in this case, if it's greater than 1, what I'm interested in is the ones where it's false. The ones that are false are the ones that are inadequate. The ones where this is true are considered adequate. Okay. So that same sort of list filter by Boolean mask comes in here. So you go through and you take the list, this list which is hanging out over here, you take this mask, okay, and then the ones that are true, or in this case, what I want are the ones that are false. Okay, so that's our lowly little inadequate door right there. Now, the issue is sort of what is true and what is false and all that good stuff really just sort of depends on, it's the direction that we're sort of putting it in there. So in this case, since I'm looking for or greater than 1, I'm looking for the false case or the out case. If I said less than 2, then I could be looking for the true case. It's really just depending on which way you're looking at it. Okay, so I have a door there. That door is actually looking pretty good. If I want to highlight that door in that room so that we can go ahead and actually see it, I can just do a little override color in view. Okay, that's really the last part of this, so that we just go ahead and get the doors, count the number of doors in each room of interest, create a Boolean for less than 2, then filter it, and then based on the doors it finds, go ahead and just override that. Okay, so let me go ahead and zoom out here, or go back over here. I could go ahead, I have 2 lists. These are the doors that are sort of inadequate. The other side is the doors that are considered adequate. So I could go through and colorize both, but if I only want to colorize the inadequate ones, I'm just going to do a little element color overriding in view. Element color override in view, or override color in view. It's hanging on to me. I got to get it to stop. It's like my mouse is still doing something weird. View. Escape isn't doing it. Oh, put a nice code block in there, which that isn't doing it either. Okay, I think I got rid of it now. Element color override in view, element. Choose it. Okay, if you want to color override those doors and kind of give a nice color like red, what we can do is basically take the doors, give them a nice color. Oh, how about color.argb? And if I want them to be bright red, because bright red sounds like it's going to be a very vivid color, I could just go ahead and make a 255 at red. Beautiful. And now when I run this, theoretically, that one door should be overridden in red. So let's go and take a look and take it back over here. Let me go switching over to just showing the walls only, as opposed to the masses. You can sort of see all the doors over there. If you want to see the room with the inadequate doors, I can go through and run this. And hopefully one of them is going to turn red. Okay, so I can sort of spot that is the room that I'm currently having troubles with. Now, it's just to sort of like experiment with this so that you sort of get a sense of does it work or doesn't work. You could go ahead and try different things. For example, this room over here actually happens to be a big room, but it has enough doors. It happens to have the 2 doors in there. If I take that out and I say run, that room should sort of pick up the problem too. If I go through and I add another door to that room over there, and I run it, here's sort of an interesting bug in this whole scenario. You'd think that if I reran it, that we would go through and that would sort of all of a sudden become not red on that side because there's now a second door over there. But it doesn't quite do that because when you override the color in view, it doesn't unoverride the color in view. Okay. So what I'm going to do is actually just relative to that is choose one of the doors, say select them all, and then I can right click and say that I want to, by element, it's reset them. That just kind of clears it out. What I should probably do is just in my Dynamo script go through and I select them all and do a reset in there. I'm not sure if that's a built-in function. Okay, so now, if I ran my Dynamo script, I think that this room over on the left-hand side should probably be okay. The lunchroom is probably going to be the one that has a problem right now. What you do is you choose an element or a bunch of elements, and then you say override graphics in view. element. And then we say, well, in this case, the reset button would be highlighted here. No worries. Okay, so if I run this, there should be overriding. So let's just pause there for a second. Just kind of take it all in terms of what's going on. There's a lot of things we can do to this. In the Dynamo scripts, I currently have it set up so that I'll need to highlight the doors. Another thing you can do is say, let's get all the walls that are part of one of those rooms and then highlight all those walls. Okay. What we do there is we go to the room and we get the bounding elements of the room, which are the walls, and we go ahead and highlight those walls. But let's go ahead and kind of think about other things we might do with this, because it's really kind of a very good general purpose thing. For example, another criteria we can look at is the whole issue of like the number of windows or the window area versus the square footage. And again, the guideline there is generally for saying that we're providing natural lighting, not whether it's good daylighting or not, but just natural lighting, we'd like to have 10% of the floor area kind of available in window area. Okay. So let's go ahead and think about how we might implement something like that in this kind of script, because it's actually just a very small variation. But let's go ahead and see if we can figure out where it would go. At some level, I'm still going to go over and, oh, what am I going to do? I'm going to grab a whole bunch of rooms. That sort of makes sense. Okay. I also have to grab the area of the rooms, which is right down here. So if the criteria I'm trying to go through and compare against is just area times 10%, I can go through and compute that. So let's see if we can go through and just got to do a calculation like that. I'll just sort of do a code block, and I'm going to say it's the room area times 0.1. Actually, I think I need the 0.1, because I've learned. So I can take all those different room areas, pop them on in there, okay, and I'm going to compute a series of values. So this is my list of values. I need 88 square feet of window in the first room, 26 square feet of window, 46 square feet of window, and 130 square feet of window. Okay, if I'm using the 10% rule. Okay, let's see how we can go through and use this. I'll just pull that up here a little bit. I got a list of rooms. Let me just stop highlighting those rooms over there. Actually, I'll just leave that for now. Okay, if I wanted to get all the windows in a room, have you seen any functions that'll do something like that lately? Okay, so let's go back and say it's really room. Retrieves all the windows that are associated with a room. Okay, I can grab all those. What I want to do is basically pull in all of the room elements. In terms of the phase, it's the same stuff that is over here. So maybe I'll just pull this further down here so I can use the same information. It's basically going to be the document phase and phase 1. Because what I want to do is get a list of windows sort of organized in each and every room. Okay, so let's go ahead and try that. Actually, at this point, I don't really have a lot of windows in there, so we need to go through and add some just to sort of give ourselves something. Come back over here. Oh, actually, I have a few windows over there. Let me put a few more windows in. So I should get a list of little windows in each room. Let's go ahead and run this and sort of see how it looks. started. Oh, let me make sure that I have stopped placing windows, because you'll remember last time if I was still placing windows, it waited. So I'm going to click the modify. Not you. Got to bring that back up again. So now, looks like it's all empty. That doesn't look very good at all.
That's what I have as well.
Well, let us see if we can figure this out. I'm in phase 1. I got a bunch of windows.
Give me windows.
What's that?
Give me windows.
Gave you windows. Let's see if we can figure out what the difference is. I got a bunch of rooms.
Or you want to get the item at the index. You connected it to phase, which is from document.phases.
Oh.
Tracking it out.
Correct. Thank you, sir. I need to sort of just get that one phase.
Yeah. Now I need it.
Okay. Again, there's this funny thing when you're standing up here, you never see what you're supposed to see. Okay, what I would like to do is basically go through and for each of these different rooms, I'd like to go through in every room and say, let's go through and evaluate the area of the window in each of that room. Okay. This might actually require a custom node or something like that, because what I really want to do is go into every room, and in every room, okay, say of those windows, what is the area of each of those windows, and go through and compute that together. So I might make it a little bit of hierarchy to make this happen in here. But the basic structure is going to be, we're going to do a list map. Where the list map's going to have some new custom function, but what's going to happen is for every item in this list, where the list is the list of windows in each of the different rooms, okay, I'd like to go through and bring that one in. Okay, but then I need a function which is going to go through and compute, for the different things that I'm popping in. Like the list of, or the actual area of the windows. Let me try something very simple though, just to sort of give a sense, because we won't get it all done in the next few minutes here. But if I just even went through and, I don't think there's a window area function. Let's sort of see if there is. I don't think there is. So if I just sort of map this out conceptually, let's think about what we're going to have to do. We're going to go through, and for each of those different window objects, we're going to go through and get 2 parameters. We're going to get its height, and we're going to get its width. And then we're going to multiply them together to return an area for each of the window.
Doesn't say that as supposed to do.
Exactly. So it's a list. So it's exactly that you know exactly what we need to do. So what it is, I'm going to feed this in. What I'm going to do is first feed in each room. Then in each room, we're going to go ahead and put a custom node in that, which computes the area, and inside that internal node, it'll say for every window, get parameter height, get parameter width, multiply them together, return the area. So the room will have a list of areas that you can sum together. Okay. And then finally, that'll return basically the total area in each room. Okay, so let's go ahead and do this. I'll do that now for anyone who wants to stick around and watch. It's 12:20, so if you need to get on to your next class, please go on and get off to your next class and what you need to do. It'll be on the tail end of the tape if you actually want to see that happening. Okay, just because that's not too awfully bad. So I'm going to go through and create a new custom node. It's going to be rooms, window area in a room. Take care.
Window area.
So in this one, what I'm going to do is have an input, which is just the list of rooms. Okay, and for every room, we're going to basically go through and do some computing, which is going to be another custom node. Let me go ahead and save this as, and I'm going to put it in example 15.1 also, just so we have it. Take care.
Why is it not showing CEE 220 in the nodes?
Oh, in the list over on the side?
No, when I save the nodes in the category, it's not showing CEE.
Oh, you just have to type it in as a new one.
It's still not accepted.
No? Let's see what happens.
Okay, it did. Sorry. False now. You don't need it.
Okay, for every different room, let's go ahead, and again, we're going to have to do something in there. What we're going to do is create a node which is going to list a list of areas, so it's going to basically, for every room, no, actually, basically, it's not going to be a room. It's the windows in a room.
Windows.
Okay, then we're going to set up a list map in here. Which is going to take the list of windows in a room, and it's basically going to return the area of each window. Okay, so let me do a new function right here. Okay, and we'll say window, area of window. And again, I'm going to make that CE 120, and we'll see if we can put this all together just for the folks on tape. Okay, let me save as. Okay, this one's going to have an input, which is going to be a single window. Okay, so once we have that window, I can say, let's go ahead and element, I'm going to get parameter by name. So I'll take that window, and I'm going to go through and get its height. I'm going to go through and get its width. I should check to make sure that I'm actually spelling these right in terms of the capitalization and stuff like that. So with those two different things, if I have those values, I can go through and compute window height times window width. Okay, that should give me an output, which is area. Okay, let's just check to make sure those are actually correct in terms of the parameter names. Otherwise, it won't work. We'll say that is going to be height and width. Okay, that looks pretty good. So that should be able to compute for any individual window. That should give me the window area. Go ahead and save that away. I'll come back over to the windows in the room. This is going to now be the function that we just put in there. It's basically our window area of window. So we have the windows, we have a list map. It'll feed in each window. It should return now basically a list of the different areas in each of the windows. So what I need to do is just do a math sum of those. Okay, and then we will have an output. Which is going to be the total area of all the windows in the room. Okay, save that away. So come back over here. I now have the Windows area in the room. So if I map that and I pull that over here, okay, we should at long last have something that will go through and through 2 levels go through and compute not only the window area of each window, but the window area in the room. Let me try and run it. We'll put it right there. But just see if we did any good there. There's no doubt a few little typos in there somewhere along the way, but we'll see how it did.
Seem to work. Oh,
Did it work for you?
no, not vectors.
No worries. Let's just sort of see what's going on. I'm still running. Oh, I'm still modifying Windows. That's why. I always have to get out of this. Is it still working? Oh, it looks like it tried. Let's see what's happening here. That's interesting. Let's see what's actually doing there. Okay, so for the Windows area in the room, it's just a big old flat list right now. Okay, we've got to do a little debugging on this in terms of what's figuring out, but we again have these windows over here. Well, I still have those empty lists. That's probably a mistake. I probably need to go through and only sort of send it to ones where it does have something. It is interesting that, okay, most of them gave 0. Okay, the ones that gave null were the rooms where it actually was doing something.
Yeah.
Let's go ahead and sort of see if we can debug it at all.
I don't have any null or any empty lists.
Let's see what I got in here. So if I edit the custom node, that should be the list of different windows, although I wonder if we somehow have to tell it that is a list coming in or something like that in the window area, blah, blah, blah. Let's just go ahead and put a couple watches in here just to do some debugging. So that should be the windows that came in. Those should be the areas that came back. Let's sort of see if there's anything going on there first, because that's always, then we'll get into the lower level node. The key to all this stuff when you have the custom nodes is trying to figure out where does the null get introduced. Okay, let's go back into our custom node. So it looks like it's doing something there. We were bringing a window in. That seems like it's okay. So list map should be able to do that, although over here, it gets a null out of there. So then my next thing is really what's happening inside window area of window. So let's open up that one. Window, element, should be there. Height, width. Let's put some watches in here. See where we're messing up. Okay, because of the type parameter. Oh, you know what it is? This is actually kind of an interesting thing. What it is I can tell you, it's element get parameter name. It's basically going against the element. The parameter is actually a parameter of the family as opposed to a parameter of the instance. So we'd have to actually go through and do a little bit of changing as opposed to sort of going through and doing the actual element. We want to sort of like, you want to get the family of the element.
Because element get parameter value is not giving me anything in element.
Exactly. So let's see if we can even do that. What I really want is the family. I want a family of an element. Let's see what I have there. Element ID. What do I have in here?
Get family parameter?
It's,
Get family parameter?
Oh, they have element get family parameter?
Yep.
They do?
Yeah.
I have parameter value. What do you got for family parameter?
So it says get family parameter.
Is it element dot or what's the start?
It starts with,
Just
I
get-
started family off and it's the third thing. So if you say family space off, OF.
Family what? A what?
Off, OF. It's the third one.
Oh.
Get family parameter.
But then you need to get the family types first.
Yeah.
And that was wondering how to get the family type of it.
No, exactly. Now what we want to do is basically get the We want it for the element, get the family that it belongs to.
Yeah.
Okay, you know we can do this. It's a matter of just sort of digging around in like Dino to figure it out. So that's why I was going after element to sort of say family. There's family types. It's going to be one of those ones where we're querying it.
Family instance.
I'll take the family types from this family, the name of this family, but that's just the family itself. I want the element family. Oh, come on in. You're fine.
Hi.
Get the family parameter. That's that there. Family, get family instance type. Oh, I'll just have to go looking for it. Let's go ahead and adjourn for today. We're going to turn off the recording for now. But I will find the function which lets us go ahead and take that and actually just sort of pull the family value as opposed to the instance value. Because
I think there's something in clockwork called element.type.
oh, what do you have for me?
Element.type.
Dot what?
Type.
Get a family. Ooh, check that out. You go. Okay. So if I take that element, let's try hooking that in there instead. You knew it existed somewhere. Okay, let's give it a run. Check it out. I got values. Okay, so room 0 has 32 square feet, 16, yada, yada, yada. I can now, that actually sort of makes sense. I can now go through and compare those to the list of requirements, get a greater than, less than, and do some sort of highlighting. Thank you, Ms. Jacqueline, for digging in and finding that for us. Okay, super. Okay, I will save that away, and we will have that as an example for next time. Okay, put it out there so we can anyone who stuck around can sort of see it. That's going to be step 6B.
Sweet.
Okay, a little shared problem solving. That's the best kind. Window areas for each room. Okay, at long last, let us adjourn.